Yeah, welcome back. Yeah. Now, Dr. T. Vinay Kumar is going to deliver on the DSPACE controller applications to power converters. Before going to the technical talk, uh, I'll introduce today's speaker. Vinay Kumar, Dr. T. Vinay Kumar received the BTech and MTech degree from JNT University, Hyderabad in 2005 and 2008 respectively, and the PhD degree in electrical engineering from NIT Warangal in 2015. In 2013, he joined the NIT Warangal as an assistant professor. His current research interests include power electronics and drives, direct torque control, relative torque control, open-end winding induction motor drives, multi-layer inverters, hybrid electric vehicles, and renewable energy interfacing. Yeah, thank you. Now over to Dr. T. Vinay Kumar. You can
Yeah,
go.
thank you, sir. Thank you for your introduction. Yeah, good morning to all. Yeah, I'm audible to everyone.
You're audible, Vinay, sir.
Yeah. Good morning to all. Myself, Dr. T. Vinay Kumar, Assistant Professor, Department of Electrical Engineering. In today's session, see the main object of lecture is we'll try to focus on uh, why DSPACE controller is required, what is the necessity of this controller compared to other controller, what are the advantages of this controller, particularly whenever you are going to control the power converters. We'll try to discuss in detail. See here, first initially what we'll do is we'll try to discuss what is the need of DSPACE, what is the advantage of DSPACE controller, right? What is the significance of this controller? We'll try to discuss next. So I got 1 hour slot for today's session. I will try to focus on why controller is required. This is a very important with respect to scholar point of view. See, as a control engineer, whenever you want to control the system, first what it required exactly we'll try to discuss, right? Why controller is required, what is the significance of the controller, right? How to identify the control objectives in particular system, what are the challenges in three-phase AC system, particularly in smart grid application or electric drive application, we'll try to discuss next. How to overcome the challenges with three-phase system, we'll try to discuss next. If time allows, we'll try to discuss what is the significance of feed forward control, where it required, right? Next, what is the significance of anti-wind up controller, we'll try to discuss in detail. Once you know the clarity about the controller, see, implementation of the control logic using DSPACE, it is not a big challenging, right? So this is the content of today's session. First we'll try to understand what is why DSPACE controller, what is the significance of DSPACE controller, what are the application fields of the DSPACE, what are the advantages of the DSPACE compared to other controllers, what are the limitations of this controller, also we'll try to discuss next. See, after discussing need and significance of the DSPACE, we'll try to focus on important things. One is control variables, how to identify. These all are fundamentals. Without knowing these fundamentals, it is very difficult to understand implementation point of view. These three topics are very important for today's session, right? What do they say? If you take any system, for a particular system, how to identify the target variables. Once you know the target variables, right, for a particular system, uh, we can easily design the control parameters. While designing the control parameters, what are the challenges when feed forward controller is required, when anti-wind up controller is required, we'll try to discuss in detail. After that, see what are the different control methods are available in literature, we'll try to discuss in detail. If possible, in today's session we'll try to focus on advanced control method, model P2 control method, I will try to explain in detail. what is the advantage of model P2 control method compared to conventional PA controller? We'll try to discuss. Right after that, before closing session, half an hour before, we'll try to discuss implementation of DSPACE for particular application. Right, next, scaling of the sensor with examples, we'll try to discuss in detail. Next, one more important thing is, this session, it should not be like unidirectional, it should be bidirectional, so that we can improve the efficiency. Right, so in between, I will try to ask the questions, key points. Right, kindly respond yourself. Right, fine, it is fine. Participants, can I ask questions in between?
Okay, sir. Fine. Fine.
Okay, now see this slide. This slide will give what is the necessity of this space, see where it will work. See, whenever you want to control particular system, see, aim is control the system, whether it is a grid connector inverter, or whether it is a drive motor, or whether it is a uh, uh, DC to for battery charging application. Whenever you see whatever application you take, see, first your job is, first you need to identify what is our system. This is a very big challenging for engineers. Right, first you need to identify, see, what is the mathematical model of the system. What is the mathematical model of the system is a very big challenging for engineers, control engineers. Once you know the mathematical model of the system, then what is the next step? This is the first step. Everyone is say you have to go through this step before control the actual system. Once you know the mathematical model of the system, what is the next step? Once you're having mathematical equation for a particular system, next important thing is you have to extract the characteristics. You have to extract the characteristics. Based on the characteristics, you need to derive the conclusion whether these characteristics are suitable for particular application or not. You need to identify. Right, whether characteristics are not matching with our requirement, then what is the next step? You have to design the controller. You have to design the controller to improve the characteristics. Right, see, the design part is also here. It is a very important to say to meet our requirement. Next, after design the controller, next big challenging is implementation. This is a very big challenging. Many of these scholars, they are struggling to, even if they identify the new control methods or new design for a particular system, see, issue is they are unable to implement in real time. Why? Because even if you take DSP controller example, DSP controller, if you want to implement your design logic or instructions to change the characteristics of the particular system based on the requirement, right? Issue is implementation. If you want to access the DSP controller, it required coding. It required actual system architecture. Without knowing the architecture of the DSP, it is very difficult to write the instructions. It may take 6 to 8 months, or sometimes it may take 1 year also. Next, see, after understanding the architecture, after developing the programming in DSP also, debugging program is very difficult. Right, so issue is here, problem is here there is a limited time is available for research scholars, those who are doing research, PhD. There is a 3 year slot is there, or 4 year slot is there, maximum 5 year slot is there. Within 5 years you have to get the paper. Right, you have to submit thesis. So maximum, say, to execute the logic, deadline is 3 to 3.5 years they are keeping. Right, within the 3.5 years, identify the problem is a big challenging. After identify the problem, right, getting solution is also another important thing. After getting solution, next, implementation, it may take 6 to 8 months. That's why if there is any time constraint is there, then you have to go for DSPACE controller. Right, see, advantage of the DSPACE controller is, once you know the new concept, right, or to change the characteristics of the actual system, you no need to worry about implementation. Once you adopt the DSPACE controller, implementation is not a big challenging. Within short period, we can implement the logic, and we can extract the physical characteristics after adopting this controller, right? This is the advantage. DSPACE controller, basically it is called rapid control prototyping system. What is the advantage of this rapid prototype system? See, whatever logic you have developed to solve the issues, how system is struggling, right? See, based on the problems facing by the actual system, right? Whatever logic you have developed to improve the performance, that logic we can implement quickly. We can implement quickly, and we can test, and we can evaluate this logic, uh, right, physically. That is the advantage. That is the advantage of rapid control prototype. See how to access this controller. At the end of today's session you will get clarity, right? Uh, before that I need to explain see what is the significance of controller. See, the object of DSPACE controller is it will execute the control logic. Finally it will give the control pulse to the power semiconductor devices, so that power semiconductor device, what it will do is it will control the energy transfer from input side to output side. Whatever output is coming from the power converter, it is under control, right, to change the characteristics of the actual system. Now, these are all the various applications of the DSPACE controller. By using DSPACE controller, particularly in autonomous driving system, e-mobility, electrification, smart grid application, grid connector inverters, robotic application, right? Position control, vibration, sound, right? Various applications you can find. See, at the end of today's session, I will try to explain what are the limitations of this controller, right? Also, we'll try to discuss in detail. See, for example, for understanding purpose, take EV propulsion system. In EV propulsion system, suppose this is the actual EV propulsion system, how we can test your control logic in laboratory session, right? So these are all the various control methods. Under software side, these are all the methods they are adopting to control the speed of the motor through power semiconductor device, right? So this logic, this mathematical logic, if you want to implement, right, through hardware, right, in general microprocessor, microcontroller, DSP, FPGA boards they are adopting, right? After executing the logic, what it will give your controller circuit, it will give control pulse to the power converter. The expected output of the electronic controller is finally it will give control pulse. This pulse will apply to the power converter. Power converter, what it will do is it will produce variable voltage and variable frequency to the system. Finally, system characteristics will change based on the customer required speed or customer required position. This is what we are doing in general. See, whenever you want to control the speed of the machine, first you have to change the reference through the software. By changing the reference, right, what will happen, according to that, see, your control logic will decide the how much duty cycle is required to the power semiconductor device, so that, right, power semiconductor device, according to requirement, it will change the RMS and frequency applied to the system, so that system characteristics will change. Now issue is, in today's session we'll try to discuss, our main object of today's session is control logic implemented. This control logic will come under software category. How to develop this logic, right? What is the significance of this logic, right? See, whenever you want to develop some logic to the system, right, how to choose the objectives, control objectives we'll try to discuss. Control objectives, system to system, it will vary. In today's session, for example, I will take simple uh, uh, DC motor, so that you will get more clarity about how to identify the control objectives. Next, suppose if your system is a three-phase system, grid connected inverter, let us assume that, take grid connected inverter. What are the challenges? If it is a three-phase system, we don't have any option, you need to adopt transformation technique. What is the significance of transformation technique? What is the base for transformation technique, right? We'll try to discuss at the end. See, what are the challenges in the three-phase system, also we'll try to discuss in detail. Anyone from the participants, please tell me, right, what is the function of controller, what it will do exactly. You forget about whether it is a motor or whether it is a grid connector inverter. Basically, what is the function of the controller, what it will do basically. Anyone?
Hello, sir.
Yeah.
Sir, this is Arun Kumar.
Yeah.
Controller helps us in getting the desired output.
Yeah, getting desired output is the expected output of the controller, right? So what is the need of controller basically, what it will do exactly? See, by adopting controller we'll get expected output, that is fine, but actually with respect to system point of view, what it will do exactly?
If our characteristics are not matching as per our requirement, then we go for designing controller.
Anyone else?
Sir, the control will consider the system non-linearities or the disturbances it is going to face. So it will consider that and respond for the like it will try to make an error out of the reference output and the actual value.
Anyone else?
Sir, reduce the error between the desired output and the reference output.
Anyone? Okay, fine. Any others? See, the main objective, primary object of the controller is it will change the order of the actual system. Once controller, let us assume that this is your system. Once controller is integrated to your system, what will happen? See, overall system transfer function, overall system order will change. That is the primary object of the controller. By adopting the controller to the particular system, right? System transfer function, say system order will get effect. What is order? Order is how we can decide the order of the system based on the characteristic equation. Am I correct or not? Clear? So example, I will take example so that you will get more clarity about what is the significance of controller. See, understanding purpose, take DC machine, DC motor. I think this is everyone. See, I will take simple example so that you will get more clarity about the concept. In DC motor, what is the expected output of the motor? What is the expected output of the motor? Whether it is a DC motor or AC motor, what is the expected output? What is the output of the motor?
Sir, rated speed and torque.
Expected output of the motor is torque. Any machine, any motor, whether it is a DC motor or AC motor or multi-phase machine also, basically motor is a torque producing device, right? Based on the torque profile, we can decide what is the order of the DC motor. See, whenever you want to decide the order, you need to verify what is the expected output of the system, right? So whatever concept I'm trying to tell, this concept you can apply to your particular system to system. This output parameter will vary. Whatever concept I'm telling, this concept you can apply to your system also, right? So that we can easily understand the concept, right? Basically motor is a torque producing device. Based on the torque profile, we can decide order of the, based on the torque expression, we can decide order of the motor. If you take DC motor, the expected the mathematical model for torque generated by the DC motor is K equal to pi Ia. So from this equation, T equal to K into IF Ia. So here how many variables are there here? How many variables are there here? There are two variables are there. One is field current, another one is armature current. So these two, see, IF is current passing the field winding, IA is the current passing the armature winding, right? So this IA and IF are state variables in our system. These two variables cannot change instant to instant. Even if you know the sample of the IA or IF at particular instant, we can easily predict what is the behavior of the IA or IF at after 5 seconds, after 8 seconds, what is the behavior of the IA, we can predict, right? State variable will give the status of the system. That's why Next, the order of this equation is, it depends. Order of the equation is depends on number of state variables. Here in this equation, there are two variables are there. That's why it is called second order system. Now, question is it linear or non-linear? Whether DC motor is a linear or non-linear system. Finally, torque generated by the DC motor is in second order. So based on the number of variables in the torque expression, we can decide the order of the particular system. Our system here, understanding purpose, have taken DC machine. Now, whether it is a linear or non-linear, this equation is linear or non-linear? Participants?
Non-linear.
But what it required, whenever you want to control, with respect to high performance wise, whenever customer required high performance, not only DC machine, any system, right? See, whenever you want to improve the dynamic response, your system order should be fast. If system order is in first order, then control is very simple. But practically all systems by nature, all are in non-linear. Second order system is non-linear, third order higher than the first order system, all are, we need to consider as a non-linear. If system is non-linear, issue is we cannot change the dynamic response instant to instant, right? Why? Because see, with respect to customer point of view, speed or position, these two are requirement. Whenever you want to control the speed or position of this shaft, right, these two components all depends on the torque. If you want to do any job in mechanical system side, torque is the main cost component. By using this component, we can able to control the speed, or we can able to control the position. By control the torque, we can control the speed. By controlling the speed, we can able to control the position, right? Even if you want to control the position, you need to adjust the speed. Speed cannot change simply like that. Speed we can control through torque only, right? So while controlling the torque based on the requirement, you need to verify how many variables are involved in the torque expression. If number of variables are more, we cannot control the torque instant to instant. But see, with respect to industry point of view or practical point of view, instantaneous control is so important. Whenever you want to control system instantaneously, right, required order is 1, right? But practically all systems, not only DC machines, even if you take AC machines or any other systems also, practically all are in nonlinear condition. If it is a nonlinear condition, right, we don't have any option. You have to go for controller. You have to adopt controller. By adopting the controller, how order is changes from higher order to lower order, by taking simple method, whatever method we are adopting in undergraduate course. In undergraduate course, see, there is a popular method is there, right? What is that method? See, this is a torque profile. Natural response of the DC motor is, it is in non-linear, right? So next, what we are doing in the laboratory while controlling the motor below base speed, right? Control the speed below base speed, we are adopting armature control method. Now, what we are doing in armature control method? This method is very popular to control the speed of the DC motor. What we are doing in armature control method, throughout the operation, we are maintaining field current as a constant. This is, please not understand, this is a technique. This is a control technique. Whether it is an open loop or closed loop, you forget it. This is the concept proposed by the engineers to control the torque instantaneously. To bring the system from higher order to lower order, they have proposed this method for DC motor. By adopting armature control method, in armature control method, necessary condition is throughout the operation, you need to forcefully maintain field current as a constant. If field current is constant, then what will happen? So your torque become directly proportional to Ia. Now, so this is it. This is the beauty of control method, control logic. By adopting the controller, once you adopt armature control method to the DC machine, what will happen? Your second order system become first order. First order nothing but it is a linear. If it is a linear, instantaneously we can control. Instantaneous control is so important with respect to industrial application or wherever high performance is required, instantaneous control is required. If you want to control the speed or position instantaneously, your control variable should be linear mode, right? So simply it will not convert it from nonlinear to linear. You need to adopt some engineering technique. You need to identify the uh, uh, technique so that we can change the order of the system from second order to first order. First order system is required to improve the dynamic response. Now everyone got clarity? What is the significance of controller? Participants, now you got clarity. What is the advantage of armature control method? It is a method, it is a logic. Fine. Participants, I'm audible?
Yes, sir. Yes, sir. You are audible.
Yes, sir.
Now it is clear. What is the significance of controller? What it will do? First step,
Yes, sir.
what it will do? It will change the order of the actual system. So after changing the order, next this one, by using current controller, we can easily control the current instantaneously. We can control. Next, one more important thing is, as a electrical scholar, whenever you want to control per particular system, you need to depends on cause and effect relationship. This is a very important concept, right? Without knowing the cause and effect relationship for a particular system, right, very difficult to identify the uh, uh, control variables in a particular system, right? See, if you know the Newton's first law. What is Newton's first law? Whenever you want to change the, suppose there is an objective is there, if you want to change the position of the objective from x1 to x2 position, what it required force is required. Where, see, this is the main cause component to change the position, right? See, without force we cannot change the state. Similarly, in case of mechanical circuit side, if you want to do any job, if you want to change the speed or position, right, see what it required torque is the main cause component to change the position or speed of the shaft. That's why torque is called primary control objective in electric drive system. Similarly, let us assume that grid connected inverters requirement is they want to maintain voltage constant and frequency constant, right? See, if you want control real or reactive power, right, with minimum ripples or minimum THD, according to that you have to develop the control logic, right? You have to inject the harmonics, right, so that we can improve the input side line quality, line side current quality also we can improve, right? See, thing is, important aspect is you need to identify what are the cause and effect in a particular system. If you identify, it is not a big deal to design the controllers, right? So the main objective of today's session is understanding the how to implement the control logic in DSPACE, right? At the end of today's session you will get clarity. Before that, first you should know what is the significance of controller, what is the main object of the controller, why controller is required. Without controller, what will happen? We cannot improve the dynamic response instantaneously. If you want to improve the dynamic response instantaneously, right, you need to adopt controller. You need to, by adopting the controller, we can reduce the order and we can improve the dynamic response, right? Next. So one more important concept is, what are the challenges in AC system? Our grid connected, particularly in smart grid, say inverters you need to adopt. By using, say, inverters, three-phase inverters, you need to adopt. What are the challenges with respect to AC system, three-phase AC system? Anyone? What are the issue with three-phase system? Anyone from the participants? This is what is the issue with three-phase system, AC system?
So the unbalance is existing within the three-phase system.
Okay, unbalanced. Let us assume that system is everything is fine. Let us assume that there is no unbalance. Then
Synchronization.
synchronization. Okay, everything is fine. You see, I'm not talking about say whether AC system is balanced or unbalanced. Now everything is fine. Input side there is a say balance supply is there. Balance all signals A phase, B phase, C phase are in symmetry. Time delay is there, right? Magnitudes also fine. Peak values also matching fine. Now see for understanding purpose, can I explain here one example by taking example, right?
Order of the system increases.
Very good. Order of the system is increases compared to DC system. Order. If order is more, eliminating the nonlinear components in output variable is a very big challenge. This is a very big challenging in AC system. Whenever you want to control three-phase system through power semiconductor element, you need to take care about how many nonlinear components are involved in the system. You need to identify. Otherwise, if number of variables are involved in the output output variable is more, control become very complex. More number of feedbacks are required, more PA controllers are required, right? So control complexity become more. If problem is if control complexity is increases, again problem is steady state characteristics will degrade. You need to take care about the steady state characters. How steady state? These three are interlinked. These three are interlinked. Please try to understand. See, if number of variables are more, your system become nonlinear. If it is a nonlinear issue is control complexity become more. If your control complexity is more, issue is to execute the logic, it will take more sample time. Execution time become more. If execution time is increases, your steady state characteristics will degrade. That's why as an electrical scholar, first job is whenever you want to improve the dynamic response or whenever you want to improve the steady state response of the particular system, your job is you need to taking care about the nonlinear components in the system. Practically all systems are naturally or in nonlinear. By adopting the control mechanism, we can change the characteristics. We can improve the order. We can bring the nonlinear system into linear. That is the strength of the controller, right? So whenever you want to overcome the above challenges, you need to understand the system behavior based on the mathematics. This is the strength of the electrical scholars. See, whenever you want to understand the behavior of the particular system, we don't have any option. You have to depend on the mathematics based on the characteristic equation, right? We can easily derive the poles. What is the position of the pole? We can identify. Once you know the pole position of the particular system, right? And see pole position of the particular system, we can easily identify. Whether system response is poor or whether oscillations are involved in the system or dynamic response is poor. Each and everything you will get clarity. Whether system response is poor, you need to adopt technique. So next, one more important thing is this concept is a very, very important concept for whenever you want to control the AC system, transformation technique. This technique will reduce the complexity, but this technique will not, it will reduce the order, but it cannot bring the system from higher order to first order. This system only partially will help to reduce the order from, let on that your system is a seventh order. By adopting this technique, your seventh order system will become fourth order. It cannot. By using this technique, we cannot convert seventh order to linear mode. We cannot convert from seventh order to first order. By adopting this transformation technique, we can minimize the order, but we cannot bring to linear. Next, see, before discussing what is the what are the transformation technique we are adopting for grid connected inverters or in smart grid application, I need to ask one question: what is the basic what is the significance of this transformation? Anyone? What is the need of this transformation technique?
Sir, reduce the complexity.
No. What is the primary what is the primary object of this transformation? What it will do exactly? What is the what it will do exactly in real-time application? Anyone from the participants? What is the function, basic function? What is
We analyze the system behavior, sir. We analyze the system behavior.
Okay, we'll analyze the system behavior. Okay, anyone?
To determine gain constants.
Anyone else? Anyone? It is a technique. It is an engineering technique. It is a mathematic technique, right? By adopting this technique, we can see this one is this one will help to reduce the complexity from 7th order to example. If your system is in 7th order, it will bring from 7th order to 4th order. Anyway, this is the expected output of outcome of the transformation technique. But what exactly it will do in practical condition? See, now I will now I'm presenting one example, practical example, right? This example will whatever function is there for this technique, it is also engineering technique, right? What it will do, this is called corner mirror. In general, wherever sharp curves are there in practical condition, they are adopting this technique, right? What it will do exactly, tell me. Let on that there wherever sharp curve is there, right? Generally they are adopting this corner mirror. What is the function of this mirror? Anyone? If you understand these practical examples, definitely you will get clarity about what is the need of transformation technique in practical condition. What is the function of this one? What is the use of this one? What is the function of this mirror? Mirror will give, see, let on that there is a vehicle is there here, right? Now reference person is standing here. This is a vehicle. Let on that, see, our reference person is sitting in this vehicle. With respect to this reference person, what is the use of this transformation technique? What is the use of this mirror? This mirror will give information about first it will give information about the opposite vehicle. If there are any opposite vehicles are there, based on the available information, next thing is this reference person will control the speed of the vehicle. Otherwise let us assume that there is no transformation technique, or there is no mirror, corner mirror. What reference person will do without knowing the information about the opposite vehicle? Simply what he will do is, whether vehicle is coming opposite or not, simply he will reduce the speed, right? By reducing the speed, he will take to reach his destination will take long time. Let on that there are no vehicles. Let on that, based on the information available in the corner mirror, right? There are no vehicle. There are no opposite vehicles. What he will do? He will increase the speed and simply he will go like this with high speed. Otherwise, any opposite vehicle is there, based on the mirror information, what he will do is he will control the speeds so that we can avoid the accidents, right? So the basic need of this corner mirror is, we can get the information. Based on the information, we can control the actual system speed so that we can smoothly reach our we can save the time and reach our destination, right, within short period. So what is the primary object of this mirror? Mirror will give information. Based on the information, right, with respect to reference point of view, with respect to control point of view, we can easily control. You got my point? What is the need of transformation? In transformation, right? Basically, transformations techniques will give information about the actual systems in terms of two-phase variables. That is the primary object of the transformation. Transformation will give, see, our natural systems are always in three-phase, right? So whenever you want to extract the behavior of the three-phase system, by taking three-phase variables also we can extract the behavior. But problem is, three-phase systems are more complicated than two-phase systems, right? That's why by using to two-phase transformations, we can minimize the execution time, and also we can get the whatever information is available in three-phase, same information we can extract through two-phase variables. Once you get the information in two-phase variables, it is not a big deal to control the actual system. Got, participants? You got my point? What is the need of transformation? Basic need is getting information is the primary object of the transformation. Once you know the information, right, it is a technique. Once you know the information, once you get the information about the actual system in terms of two-phase variables, it is not a big deal to control our system. Participants, you got my point? What is the need of transformation? You got clarity?
Yes,
Yes,
sir.
sir.
Participants,
Yes, sir.
others?
Yes, sir.
See, many of the scholars, what they're thinking is this transformation will minimize the order, or transformations will reduce the order. Like that, they will think. Please not understand. By using transformation, we cannot bring the system from higher order to linear mode. But we can minimize the order, but we cannot bring into linear mode. If you want to bring the linear mode, you have to apply advanced control methods. By adopting the advanced control method, we can bring the see, there are combinations are required. By adopting this transformation technique and control technique with power electronic module, by combinations of these three techniques, we can able to bring the seventh order system to fourth order by adopting transformation. After that, it required advanced control methods. By adopting the advanced control method, what we can do is, see, by adopting these control methods, we can change the order from fourth to first order. So transformation techniques are required, transformation techniques are required. Next, advanced control methods are required, plus power electronic module. By taking this one, by taking the combinations of transformation technique, control method, and power electronic module, see, we can eliminate the nonlinear effect in the complicated AC system. Right, by using this by using the combinations of transformations, power electronic module, and advanced control methods, what we can see advantage is we can improve the dynamic response of the AC system similar to DC machine. That is the strength of this transformation technique and power electronic module. Without taking power electronic module, we cannot change the characteristics. Please try to understand. Right? See, the main object of today's session is control the power converters through DSPACE software. See, whenever you want to control the power converter, first you should know why controller is required, why control logics are required, why transformations are required. We should know. Transformations will give information. First primary object of transformations is it will give information about the actual system information in two-phase variables. It will give. Example, let us assume that, take this example. These three techniques are very popular for electrical scholars, particularly power system application, power electronic application. These three techniques they are adopting to control the system, right? So what is the primary function of the Clark transformation? See, your natural system always in three phase. By adopting the Clark transformation, what will happen? Three phase variables will convert to two phase, right? See, next, again, by adopting the Park transformation, this is about Clark transform. By adopting the Park transformation, two-phase AC variables will convert to two-phase DC. See, thing is, many of the scholars, they are thinking that Even see, by adopting Clark transformation or part transformation or cross nothing but directly three phase to three phase AC to two phase DC. See, they are thinking that characteristics will change or something. Please try to understand, characteristics will not change by adopting the transformation. By adopting the transformation technique plus advanced control methods, then only characteristics of the actual system will change. These transformations basically it will give only information in terms of two-phase variables. Once you know the information in terms of two-phase variables, after adopting the engineering technique, after adopting the design methods, design technique, we can improve the dynamic response. Otherwise, by adopting the transformation technique, many of the scholars they are thinking that dynamic response will improve. Dynamic response will not improve simply adopting the transformation technique. By adopting the transformation technique, see, we'll get information with less number of variables. Please try to understand. Let us assume that understanding purpose, take example, best example, induction motor. Why? Because this machine is very popular machine, very 80 to 90% industrial they are adopting this machine for meeting the mechanical requirement, right? So by using this, see, what is the expected output of the three-phase induction motor? Torque, this one. This is the nature of the torque generated by the three-phase induction motor. See, by taking three-phase variables, right, we can extract the behavior of the induction motor. Instead of taking three-phase variables, by taking two-phase variables also, we can extract the same information. Whatever torque generated by the three-phase system with three-phase variables, same profile we can extract with two-phase variables also. Instead of AC signals, by adopting the power transformation, what we can do is, see, same characteristics, same torque profile, we can extract with DC variables also. See here, in this case, the common point is, even if you take three-phase variables or two-phase AC variables or two-phase DC variables, see, the characteristics of the system, it won't change. The system characteristics or system behavior is same. Only thing is number of variables involved in the extracting the behavior is different, right? You got my point. One more important thing is, what is the common point among the three cases? Anyone? There is a common point is there. Next, you forget about common point. I want to ask one important question. See, what is the base for this transformation technique? Anyone? What is the base for converting three-phase to two-phase variables, AC, two-phase to two-phase DC? What is the base for this transformation technique? Anyone from the participants? See, while transferring the signals from three-phase to two-phase, what will happen? Power may vary or magnitude may vary, right? So in order to maintain, see, particularly in a smart grid application, grid connected inverter application, power should not vary. While converting the signals from three-phase to two-phase with respect to control point of view, please try to understand one more important thing is, see what is the use of this mirror. This application of this mirror is so important with respect to control point of view, right? With respect to control the speed of, with respect to control point of view, this mirror is so important. So in case of engineering application, whenever you want to control the system, particular three-phase system, complicated system, these transformation techniques are so important with respect to control point of view. With respect to control point of view, by adopting this transformation technique, we can minimize the order without losing any property. Whatever characteristics is offered by the three-phase system, same characteristics we can get with less number of variables by adopting this transformation technique, right? Now question is, what is the base for this transformation technique? Anyone from the audience, participants? While converting the signals from three-phase to two-phase AC or two-phase to two-phase DC, what is the base they will take? There is a common point is there. Common point you need to satisfy. What is the base for transferring the signals from three-phase to two-phase?
Sir, voltage.
No. Anyone? Anyone from the participants? base? Example, you forget about other application complicated. Take best example, 3-phase induction motor. Right now I want to extract the characteristics of the induction motor through this transformation technique. What is the base? See, answer is there in this PPT itself. There is a answer is see, whatever question I'm asking, there is
Sir, angle, phase angle.
no. First, what is my request is all of you try to understand the question. Still, if you are unable to understand the question, you can ask. See, my question is very simple. While converting the signals from 3-phase to 2-phase AC or 2-phase to 2-phase DC, see what is the base they are taking. There is a one parameter they are taking as a base, right? Based on that common point, they are trying to transfer the signals from 3-phase to 2-phase. Take example, drives application in induction motor application. What is the base? See, if you take 3-phase induction motor, what is the nature of net MMF? What is the nature of here? What is the nature of MMF? Is it rotating or stationary? What is the nature of MMF?
Rotating.
Even if you convert signals from 3-phase to 2-phase MMF, the nature of the MMF in 2-phase AC also it is rotating. Even if you apply power transformation also, the nature of net MMF is rotating. Even your signals are in DC. DC signals are so important. Please try to understand these signals are very important with respect to control point of view. Why? Because whenever you want to design the KP and K values for PA controllers, right? See, if your error is in DC, we can easily identify what is the cost component, what is the magnitude of cost component we need to maintain in our actual system. Your PA control will decide. If you maintain same signal with respect to motor terminal or with respect to actual system, this error will come down within 4 to 5 sample instance, right? So here, instead of taking 2-phase AC, practically with respect to control point of view, DC signals are so important. Why? Because if the error is in AC, controlling the magnitude and phase is a very big challenging for engineers, right? It is not so easy, right? That's why practically with respect to control point of view, with respect to design point of view, right, your variables should be in DC nature. If your variables are in DC nature, error also it is in DC nature. If error is DC with respect to control point of view, it will easily generate the cost component, right? You no need to taking care about the phase delay, or you no need to take care about the time delay, or you no need to worry about the phase delay also. If your error is in DC, task become very simple. Only your job is you need to concentrate on only magnitude. If your error is in AC nature, you need to take care about the magnitude as well as phase, right? That's why. So here with respect to control point of view, this cross transformation or Clark plus Park transformations are so important to convert the actual signal information, AC signal information in terms of DC. These transformations are applicable if your system is more than 2 phases. If your system is greater than or equal to 3 phases, you can adopt this transformation. By adopting this transformation, right, say problem with respect to control point of view, you will get information. Once you know the information, it is not a big deal to rectify the error, right? By choosing proper KP and K values, we can rectify the error effectively, right? You got my point, participants?
Yes, sir.
Yeah. So till now what we discussed, see what is the need of DSPACE. Why DSPACE? By using DSPACE, what we can do is we can implement the control logic quickly within short period, without required any architecture of the controller. It doesn't require, you no need to know the what type of controller we are using, what is the model of the control, what is the model of the processor. It doesn't require. See, only challenging is you need to identify the control logic. To identify the, see, before identify the control method, first you should know what is the need of controller, what is the necessity of the, what is the significance of controller. By adopting controller, order of the system will coming down. Once order is decreases, we can improve the dynamic response, right? These are all the significance of the controller, particularly in the AC system. Your system is a AC system, challenges is more number of variables are involved in the output variable. If number of variables are more, you have to adopt transformation technique, and by using transformation technique, by using advanced control methods, and by using different power electronic module combinations of these three, we can improve the dynamic behavior of the system based on the customer requirement. Right, these are all the topics we covered till now. Right, next, another important question is, see, the base for transformation signal is, see, MMF. This is the very beautiful concept. See, whenever you want to convert the signals from 3-phase to 2-phase or 2-phase to 2-phase DC, they are taking base as a MMF. Whatever MMF produced by this 3-phase system, right, same MMF you have to taking care. MMF should not vary. Resultant net MMF produced by the 3-phase and net MMF produced by 2-phase system must be same. If you satisfy this condition, if you're taking care about this parameter, it is not a big problem to meet the power invariant condition or magnitude invariant condition while transferring the signals from 3-phase to 2-phase. Power invariant condition is so important for grid connected inverter application. Whenever you want to control, particularly in smart grid application, whenever you want to control real power or reactive power, this power invariant condition transformation technique is so important. Right, even if you take drives application, magnitude invariant condition is so important. Right, so example here, this is the numerical example. By taking this numerical example, we can understand what is the significance of while transferring the signal, what is the base, whether MMF of the 3-phase system and 2-phase system is maintaining constant or not. Right, this by after going through this example, you will get clarity. This is the mathematical model of the 3-phase currents. Right, so let us assume that your peak current is 1 amp. So instant will take theta equal to 30 degrees. By taking this instant, what will happen, number of turns in the A phase, B phase, C phase, assume that it is 100 number of turns. So calculate A phase MMF, B phase MMF, C phase MMF. One more important thing is, see, particularly our system is a complex system. Our AC system, it is not a real system, it is a complex system. Complex system, nothing but you need to take care about the real as well as imaginary component. Your vector is placed when a vector, see, AC system, it is not a simply like it is only represented by one axis. It is a complex system. You need to take care about the magnitude and phase also. That's why it is called complex system. AC system is a complex, real and imaginary component you need to take. So here, if you take this 1 amp, peak value is 1 amp and instant 30 degrees, what is the resultant MMF? If you add these three, net MMF becomes 0. You should not add. Why? Because simply you should not take arithmetic addition. You have to take phasor addition. Why? Because our system is a complex system. If it is a complex, you need to take care about phasor. This is the A phase MMF is 50, B phase MMF is minus 100, right? Minus 100, C phase MMF is 50. If you add this one, net MMF become 150 ampere turn. Net 150 ampere turn. This is the nature of resultant MMF produced by the 3-phase system. Now here, let us on that we'll apply Clark transformation. The significance of Clark transformation while converting the variables, 3-phase variables to 2-phase, right? By taking this coefficient, we can maintain magnitude invariant. Magnitude invariant condition is so important for drives application. See, by using, whenever you want to control the torque generated by the AC machines, generally they are adopting this magnitude invariant condition. In magnitude invariant condition, this factor is so important. Even if you take magnitude invariant condition and substitute here, take same instant, finally a net MMF produced by the 2-phase system is also 150 ampere turn. Right? Even if you take magnitude variant, nothing but power invariant condition. Even if you adopt power invariant condition, right, net MMF won't change. Nothing but this power invariant condition is so important in case of grid connected inverters, right? Whenever you want to control real or reactive power effectively, they are using this coefficient. Coefficient of the transformation matrix is square root of 2/3, right? This one coefficient, generally they will calculate based on the MMF. MMF is so important while converting the signals from 3-phase to 2-phase. MMF should not vary. Whatever MMF produced by the 3-phase system, same MMF if you maintain, it is not a big deal to convert the signals from information from 3-phase to 2-phase with less number of variables. Right now, I want to explain one more important thing. This is a very popular transfer function model for the DC machine. By using this model, I want to explain one more. I want to tell one more important controller. You heard about feed forward controller? Anyone from the participant? Participants? You know about
Yes,
feed
sir.
forward controller? Anyone from the participants? What is the significance of feed forward controller? Where it required? At least you heard name about this feed forward controller? Participants? What is the object of this feed forward controller? Anyone? See, whether it is a feed forward controller or feedback controller, any controller,
Improve the response system, sir.
main object is it will reduce the order of the system and it will eliminate the effect of the dominant pole in the system. It will eliminate the effect of the dominant pole. Whether, see, this one in general practically, see whether first you need to understand what are the characteristics of the actual system. See, based on the characteristic equation of the actual system, right, if there is any dominant pole is there or not, you need to identify. If pole is closely to origin, then system response will become very poor. By using this feed forward controller, this is one of the engineering technique, feed forward technique, to eliminate the effect of the dominant pole. Right? See, important point is, see, when this controller is required, you have to analyze. This is a very important point for design engineers. Whenever you want to adopt something, right, first how system is struggling, you have to understand. Right, if there are any dominant poles, if there is any dominant pole is there in the system, right, immediately you have to take action. As a controller, you have to take action, right, so that what will happen, you need to eliminate the effect of the dominant pole. In today's session, for understand the significance of feed forward controller, I will take simple characteristic equation. This is the characteristic equation of the DC machine. By taking this characteristic equation, we can understand what is the need of feed forward controller. We can understand. I think this equation is very familiar to everyone. Am I correct or not? This equation is very popular for see, you know this equation, right? Everyone, participants. If any problem, see, if you are unable to understand this equation, you can ask. This is the mathematical model for armature voltage in case of DC machine. This is called characteristic equation of the armature circuit. Can I ask one question here? Participants?
Yes, sir.
Now in this equation, what is the output variable? What is the input variable? What variable will create problem in this characteristic equation? What variable really will create the delay in the response? If you understand this characteristic equation, if you understand the behavior of this equation, it is not a big deal to design the control parameter through DSPACE software. See, DSPACE software, see, we are not here to market as the DSPACE software. See, now we are here to explain the what is the, see, how we can utilize the DSPACE software. See, see, in this session, I will try to demonstrate the DSPACE software at the end of this today's session. See, how DSPACE, what are the models, see, how many models, each and everything I will explain. But see, my aim is, see, whenever you want to implement something, what it required exactly, I'm trying to focus on in today's session. See, this is simple code. This definitely, see, at the end of today's session, you will get clarity about what is the need of controller, what is the significance of controller, what is the use of feed forward controller, what is the use of anti-vendor controller, what is the use of transformation. Everything you will get clarity at the end of today's session. At the same time, before closing today's session, I will try to demonstrate the DSPACE controller, how to access the DSPACE controller. I will try to explain in detail. Now, before that, see, as an electrical scholar, your job is identify the problem. Extracting the problem is a very big challenge. Identify the problem. Once you know the problem, right? See, based on the problem, right, how system is struggling, you have to identify, right? Once you know the problems with respect to particular system, solution we can find. Once you know the solution, right, through DSPACE software, it is not a big deal to implement. Here issue is many of the scholars, they are struggling here. That's why I'm trying to focus on identify the problem. What is the problem with this equation? This is the called nature of the equation, nature of the armature circuit. The nature of the armature circuit, mathematically we can represent by VA equal to RA IA plus LA DIA by DT plus EA. Right? Am I correct or not? So in this equation, what is the state variable? What is the control variable? What is the which variable will create the disturbance in the system? Anyone?
Sir, armature current is because it's a rate of change.
Armature current is
Is a function of the differentiation. Is a rate of it's a changing with the time.
That is control variable, sir. IA.
IA is the
Control variable.
anyone? What is IA? What is IA in this equation? What is EA in this equation? What is VA is in this equation? There are three variables are there. VA is one variable, IA is another variable, EA is, there are three variables are involved in the armature circuit. Now what is the, see, what is EA, what is IA, what is VA? VA is called input variable to the system, where VA is the applied voltage across the armature circuit. This is called input. IA is the output variable of the armature circuit. EA is acting as a disturbance. Am I correct or not?
Yes.
Clear? Take transfer function model. Here transfer function is there. This is about transfer function model of the apply Laplace transform to this equation. Then you will get this one. So based on this equation, we can conclude that this is the transfer function model of the armature circuit. Expected output of the transfer function model is IA. Right? What is the input to the system? Input is VA. Then this one EB is acting as a disturbance. Now, as an electrical scholar, your job is you need to identify. See, whenever you want to control the IA, torque we can control through IA. By controlling the IA effectively, right? How we can control the IA? Through VA. By controlling the VA input to the transfer function model, we can control the IA. But issue is whenever you want to control the IA with respect to control point of view, with respect, this is very important, with respect to control point of view, this EB is acting as a disturbance. This signal is acting as a unwanted signal. See, whenever you want to control the torque to change the position of the speed of the drive, whenever you want to control the speed, you need to control the torque. Whenever you want to control the torque, you need to control the IA. Whenever you want to control the IA, you need to control VA through this VA. It will come from the power electronic model. But issue is with respect to control pulse or reference with respect to controller, this EB is acting as a disturbance. Your job is you need to identify this EB is acting, EB is really creating, even though it is a disturbance, you need to identify whether it is really creating harm in the circuit or not. You need to identify whether it is really creating harm to the response of the IA. Your job is you have to eliminate the effect of this disturbance. To eliminate the, whether first we'll identify, see, this is the mathematical model of the armature current versus armature voltage, output response of the armature circuit versus input voltage. Output response of the armature circuit is IA. Input parameter is the VA. right? Transfer function model is nothing but output response by input signal, right? So if you derive the transfer function model for the armature circuit, this is what you will get. Finally, you will get, see, if you take the characteristic equation, there are two poles are involved in the system. One pole where tau A is the electrical pole, right? Tau M is the mechanical pole. This mechanical pole is mainly because of back EMF. It is entering in the system back because of back EMF. Back EMF is directly proportional to omega m, right? Omega m is the output of the mechanical circuit, right? Mechanical system transfer function model is 1 by Js plus 1 by Js plus B. So finally, because of back EMF, what will happen? Mechanical time constant is involved in the electrical circuit. Basically, your armature circuit is electrical circuit. But problem is, once back EMF is entering the picture, right? See, while control the current, there is a mechanical time constant is entering in the picture. So the nature of the mechanical time constant, tau m, there are two poles are there, one by tau m, one by tau a. Tau a, practically it is very less. If tau a is very less, pole position, P1 position is very far. P1 position is very far from the origin. So tau m is very, very high. If tau m is very, very high, P2 position, pole offered by the armature circuit, right, due to back EMF is very high. Time constant is very high, so that pole position is closely to 0. P2 is closely to 0, right? So what is the problem? See, issue is once back EMF is entering in the picture, what will happen? Bandwidth of the circuit is decreasing. Bandwidth is nothing but distance between the origin to dominant pole. If bandwidth is less, ability to track its reference is very poor, right? So as a electrical scholar, as a designer in any system, first you need to extract the characteristics of equation of the system. In characteristic equation, any signal is creating disturbance or not, you need to identify. If disturbance signal is really creating harm in the response, we don't have any option, you need to adopt technique. So here, please try to understand, here disturbance is back EMF. Because of back EMF, what is the harm? Dominant pole is entering in the picture, right? If dominant pole is there, bandwidth of the system will decreases, ability to track its reference will decreases. We cannot control the current instant to instant because of this dominant pole. That's why you need to adopt feed forward controller. This feed forward controller, generally they are adopting to eliminate the effect of the dominant pole practically. Whenever you want to control the particular system using closed loop mechanism, right? This feed forward controller, they are adopting to eliminate the effect of the disturbance in the system, right? By adopting the feed forward controller, here what they will do, this is our controller, right? This is our system. With respect to our system, right, this is our DC machine, this is our controller. With respect to controller, this signal is acting as a disturbance. To eliminate the effect of disturbance, simply your job is, with respect to control point of view, next one more important thing is you should know what is the polarity of the disturbance. If polarity of the disturbance is negative, you need to inject the positive back EMF with respect to controller. If you add positive back EMF signal with respect to controller, then what will happen with respect to this reference point? See, back EMF minus back EMF plus back EMF both will cancel to each other with respect to this reference point. What will happen? Here, effect of the dominant pole will eliminated with respect to this reference point. This is the transfer function model after adopting this feed forward controller. This is the significance of feed forward controller. If you adopt, see, by using feed forward controller, we can eliminate the effect of the dominant pole. By adopting a feed forward controller, what will happen? We can improve the bandwidth. Once, see, bandwidth of the system is improved, then automatically the dynamics of the IA will increases. See, IA dynamic response is only depends on the electrical pole. Earlier it was mainly depends on mechanical pole. Mechanical pole position is very closely to origin. In that case, see, very difficult. So see, after adopting the feed forward control method, you can see what is the response of the system. See here, this first waveform, this is the speed response of the separately excited motor without back EMF compensation or without feed forward controller. This is the response of the system, speed response of the system with back EMF compensation method, right? What is the advantage here? With back EMF system, you can see with feed forward controller, your system it is settling here. Your settling time is at 0.04, but here your system is settling at 0.0 second. Now you can see by adopting the feed forward control method, we can eliminate the effect of the back EMF. We can eliminate the effect of dominant pole. What is the advantage if dominant pole effect is eliminated in the actual system, right? Advantage is your output response will settle immediately, right? Your dynamic response will improve. If you want to improve the dynamic response, you have to bring the pole far from the origin. If you want to bring the pole position far from the origin, right, you need to identify, right, any dominant poles are there in the system or not. You need to identify. How we can identify the dominant pole? Based on the characteristic equation. I'm required. See, what is my suggestion is, whenever you want to control the system, particularly whether it is a simulation or hardware, right, important thing is you need to analyze the system characteristics in detail, right? After that, after analyzing the system characteristics, you have to identify any disturbances are there in the system or not. You need to identify. If there are any disturbances are there, immediately, whether disturbance is creating really harm or not, you need to identify. If it is really creating harm, then you need to adopt controller, feed forward controller. By adopting feed forward controller, what we have done here, we eliminate the effect of the mechanical pole. Mechanical pole position is always closely to origin, right? Now, participants, you got clarity about the control significance of the controller.
Yes, sir.
Others, participants, participants.
Yes, sir.
Yeah. Now come to this role. This role the various control techniques for converter application. By using these techniques, we can control the characteristic. We can convert the energy from say AC to DC or DC to, we can see hysteresis controller, linear controller. Under linear controller, PA controllers are there, sliding mode controller, predictive controller, artificial. See, what is my request is, even if you take any controller, important thing is, right, you need to identify the actual system characteristics, right? See, if you know mathematical model of the actual system, more clarity, then you can go for this method. These two methods are very popular, right, to improve the response of the actual system in dynamic state as well as steady state condition, right? So under predictive controller, this model predictive control techniques are so important, so advantage compared to other deadbeat controller, right? Now see, now time almost 11:50. Within 10 minutes I will try to conclude this session. Now see, by using this slide without effect, see, without spending more time, I can tell what is the advantage of model predictive controller compared to conventional PA controllers. Most of the engineers see, for their research work, they're adopting PA controller instead of PA controller. If you adopt model predictive controller, right, your steady state response will improve. But thing is, whenever you want to implement model predictive controller, necessary thing is it requires two things. Your controller must be digital controller. You have to adopt digital controller, right? Plus you should know actual system model. Without knowing the actual system model and without adopting the discrete controller, we cannot implement model predictive. This model predictive controller is applicable only for digital. Using analog controllers, we cannot implement this model predictive controller, this, right? By using DSP or FPGA boards, we can implement this controller effectively. So what is the basic difference between PA controller and model predictive controller? By using this slide, we can understand. Anyone from the participants, if you know what is the difference between these two, if you know, you can tell. From the participants, what is the basic difference between PA controller and model predictive controller? Participants, you know about model predictive control? Participants, at least you
Can
heard them.
can estimate the future value of.
Okay, anyone? Anyone from the participants? See, this model predictor controller will give the information about, see, what voltage we need to apply in the next sample period. It will give information. See, the basic difference between PA controller and model predictor controller is what we are doing in PA controller. See, PA controller at t equal to kth instant, we are calculating. See, what is the error you will get at kth instant. Then see, then in same instant, what is the required voltage you will calculate. But issue with PA controller is this voltage vector will apply at k plus 1 instant. Whatever error you want to rectify, right, your PA controller will give what is the how much voltage we need to apply across system, your PA controller will give. But problem is this voltage will apply practically in the next sample period. This voltage will apply at kth instant in real time application. What is the problem? If you apply v of k at k plus 1 instant, this voltage vector is responsible for eliminating the error at t equal to kth instant. But problem is we are applying this voltage vector at k plus 1 instant. Whatever voltage vector we are applying at k plus 1 instant, that voltage vector really it will not help to rectify the error at k plus 1 instant. This is the issue with conventional PA controller. But if you take model predictor controller, your model predictor controller, based on the error, they will predict the error k plus 1 at kth instant itself. They will identify the what is the behavior of the error at k plus 1 instant, what is the required voltage for k plus 1 instant. They will calculate at kth instant itself. Finally, whatever voltage vector is decided at kth instant, that voltage v of k plus 1 will apply at k plus 1 instant only. So this voltage vector will take responsibility to eliminate the error effectively at k plus 1 instant. This is the basic difference between model predictor controller and PA controller. PA controller, there is a sample difference is there in voltage vector. Whatever voltage vector is you are applying at particular sample, really that voltage vector is not responsible for eliminating the current error. It is responsible for eliminating the error in the previous sample. That's why what will happen if you verify the response. See, this is the PA controller or hysteresis controller. This is the response after adopting PA controller. If you verify this response, steady state response is improved with control technique, model predictor control technique. Advantage is, see, we are predicting the state one sample ahead. What voltage vector we need to apply in the coming sample, we are predicting, and we are applying voltage vector more accurately so that we can eliminate the effect, we can eliminate the error effectively. This is the advantage of model predictor control method. Now come to implementation. How to implement the DSPACE. See, till now we have discussed what is the significance of controller, what is DSPACE, right? While implementing the DSPACE, please try to understand, it is a module. It is a combination of software and hardware module. By taking the combination of software and hardware module, we can easily execute the logic without coding. It doesn't require any coding, right? Simply, if you know the mathematical model of the actual system, we can easily implement mathematical model in MATLAB software. Through MATLAB software, we can execute the logic and we can transfer the data to the controller. Next, one more important thing is this one, synchronizing the system, right? System and controller, this is very important, right? Your system is always in continuous section, but your controller is always sample time, right? Now this is about control board of the DSPACE 1104 module, right? This is the architecture of the DSPACE 1104. There are two primary if you take DSPACE controller, finally there are two controllers are there. One is microcontroller, another one is DSP processor. This DSP processor is acting as a slave. This processor is acting as a master, right? Most of the cases, by using master controller itself, we can execute the logic, right? Whenever you want to execute, whenever you want to adopt slave also, it is fine, no issue. But most of the cases, engineers, scholars, they are adopting by using master controller itself. We can execute the logic, right? right? This is about dongle USB flash drive. If you want to access the DSPACE controller, this dongle is required. Without this dongle, we cannot access the controller. This is a control panel. By using this panel, this is called IO panel, input output panel. By using this panel, we can extract the data from the controller. This is a very important digital input output panel, right? So by using digital IO pins, we can extract the data from the controller. Finally, controller output is pulses. If you take any control logic, finally, if you execute the logic through DSPACE software, right, software and hardware combination, finally we can extract the pulses. These pulses we have to apply to the power electronic module. The expected output of the digital IO output pins are control pulse, right? So if you want to activate slave also, you can activate slave. By using slave DSP processor, we can extract the control pulse here. Most of the cases, by using master controller itself, we can extract the pulses. Next, here DACs are available, digital to analog controller. Next, analog to digital controllers are required, right? So by using analog to digital controller, we can send it analog signal to the controller in digital platform. Next, one more important thing is, while transferring the signals from analog system to digital signal, you need to take care about the voltage ratings. So voltage rating of the ADCs and ADCs should not go beyond the 5 volts. Voltage should be always 5 volts. Whatever signal you are applying to the ADC, that voltage magnitude effective value should not go beyond the 5 volts, right? So that is the rating of the ADC. That's why we should not go beyond the 5 volts. You have to take care. So here, by taking this simple example, I will try to explain how we are protecting the ADCs from the higher voltages. By taking this example, we can understand. Next, at the same time, after scaling down the signal, again with respect to control point of view, again you need to amplify the magnitude so that you will get actual speed of the system in digital platform. So this is about scaling of the sensor. So let us on that motor is there. Motor is connected to, so my aim is sensing the speed through tachometer and sending the signal to the DSPACE controller through ADC. Now see, if you want transfer the analog signal to the digital platform, the scaling factor is so important. What is the function of tacho generator? Anyone? What it will do exactly? Participants? Anyone?
Convert speed to the voltage signal.
Very good. So input to the tachometer is speed, right? Speed is the input, output is the voltage. Let us assume that whatever tacho generator we are having in the laboratory, the rating of the tachometer is, see, it will produce 50 volts whenever your speed is rotating with 1000 RPM. This is the specifications of the tachometer. This is input, this is the output, right? So based on the input and output rating of the tachometer, right, we can decide what is the gain of the tachometer. What is the gain of the tachometer here? Input is 1000 RPM, output is 15 volts. What is the scaling? I will explain later. Now let us assume that here this one maximum rating of the motor is 1500 RPM. Let us assume that 1500. What is the maximum VDC here? If it is a 1500 RPM, maximum VDC, it will go 75 volts. If it is a 75 volts, you should not apply 75 volts to the ADC. You have to step down. By using potentiometer, we can step down the voltages, right? So that here 75 to, by using this potentiometer, we can able to convert 75 volts to 5 volts. Here also there is a scaling is there. So 1500 RPM we are converting to 75 volts. Between the, see, tachometer, it is having its own gain. Now potentiometer is also, it is having its own gain. Input is 75, output is 5 volts. This 5 volts, let us have that, by applying this 5 volts to the ADC, what it will do is this analog signal will convert it to digital signal, and also we can protect the ADC from the higher voltages. Finally, whatever signal is coming here, this signal, it is in digital platform, right? This signal you have to convert it in terms of what is the speed of the actual motor. That information is required. Here you are getting the signal information in terms of voltage, digital voltage, right? How we can convert the voltage, digital voltage, into speed information? That is based on scaling. This is a very important in DSPACE controller, not only DSPACE, any controller, right? If you want convert analog signal to digital signal, first you need to take care about the analog signal magnitude. If analog signal magnitude is beyond the 5 volts, you have to take care about the values. By using potentiometer, we can step down, right? So by stepping down the signals, we can protect the ADC from the higher voltages. But thing is, after converting the signal from ADC, right, whatever information is coming here, that information you have to take care. You have to convert in terms of speed, right? By taking care about the see, let us on that rated speed is 1420 rpm, then tachometer output is 71 volts. Here, this is the output of the tachometer. This is the input. See, this is the output of the tachometer is 71 volts, right? So 71 volts is the input to the potentiometer. Potentiometer output is 5 volts. Let us on that 5 volts. So here, how we can convert this gain? ADC gain is 1/10. Here ADC also, it is having its own gain. Potentiometer is also having its own gain, right? Tachometer is also having its own gain. Now my question is, how to design the gain, how to design the scaling? This is a multiplier. By using this multiplier, by using proper multiplier value, we can extract the actual system information in digital platform. This is a very important, right? How much gain is required? Anyone from participants, how much gain is required to get the exact speed? Let them that speed is 1420 rpm. Now I want to get 1420 rpm information with available here. ADC gain is also 1/10. What is gain here? How much gain? This is the gain. 2840 is the gain of the multiplier. By using this gain, we can easily whatever signal is there, we can amplify the signal, right? And we can get 1440 rpm information in digital platform. How we can calculate this gain? See here, it is a very simple, right? Here, see, 1000 by 50, 1000 by 50 is the 20 is the gain of the tachometer. Next, 71 by 5, this is the gain of the this one. Next, here 1/10 is the gain. Then if you reverse the gain of this one, definitely you will get 2000. If you multiply 20, right, 20 into 71 by 5 into 10, you will get 2840. If you want, you can verify. Only thing is, you need to multiply of the each stages. This is the stage 1, this is the stage 2, this is the 3 stages. There are 3 stages are there, right, to get the actual information in digital platform. This is how we are doing in the laboratories to scaling to find the gain value, sensing to sense the speed, right? One more important thing is this is very important thing, real-time control timing. See, whenever you want to execute the program, you need to define the sample period. How they will define based on the execution time. If execution time, if execution time is 10 microsecond, right, sample time you have to take at least 1.5 times of the execution time. Then only after completion of each sample, you can expect the output, or you can expect the control pulse to regulate the characteristics of the actual system, right? Now this is about practically DSPACE software we can access through DSPACE controller, we can access through MATLAB software. Once MATLAB is integrated to DSPACE software, you will get this window, right? RTI blocks or real-time interface blocks are not available in offline MATLAB. Once your MATLAB is integrated to DSPACE software, then this MATLAB is called real-time MATLAB, right? So through this MATLAB, we can access the controller. Clear? So if you go through the DSPACE software, these are all the blocks, right? Master and slave blocks are available. Inbuilt blocks are there. See, if you go through the slave controller, this PWM pins are available. Next, if you go through the master, ADCs are available. We can access ADCs. We can access DACs, and we can access encoder setup is also available. IO pins and uh, master IO, master input and master output pins are available. Using this master input and output, see, master output pins are so important to transfer the pulse from the controller to the IO panel. IO board, we have seen IO board, right? So see, by using these master pins, we can extract the signals through IO panel. Now here, this is the simple example by using this is called simple sine triangle method. By using simple sine triangle method, we can generate the control pulse. Later on that, this is our required speed. To meet this required speed, how much voltage is required, how much angle is required, we can calculate through this logic. This is called V by F method. Finally, using voltage, magnitude and angle, we can calculate the magnitude of the A phase, B phase, C phase. These three signals we can compare with high frequency carrier waveform. Finally, you will get pulses. These pulses, see, A phase, B phase, C phase pulses, we need to transfer to the IO panel. If you want to access the IO panel, you have to take corresponding block. By taking this IO output block or master output bit block, we can access this pulses through hardware. These pulses, right, we can easily apply to the power electronic model. So that this is, please try to understand, this is called real-time Simulink block through DSPACE software. This RTA block is available. See, if you take offline MATLAB, you won't get this icon, right? But once you install the DSPACE software and integrated this MATLAB to the DSPACE software and hardware, then you will get this block. This is called implementation of V by F method through DSPACE software. Here, see, only thing is, by doing practice, we can understand the concept. It is not a big deal. Right? Next, one more important thing is this control desk is very important. Your MATLAB is acting as a only front end. Whatever input you want to transfer to the controller, we can transfer. Once your program is executed, right? Important thing is, if you want to access the variables in dynamically through control desk, we can access. Through control desk, it is possible to change the variable. Suppose at t equal to 0, your reference speed is 1000 RPM. This initially we can define what is the reference speed through MATLAB, we can define, but at t equal to 10 seconds, if you want to change the speed from 1000 to 500 through MATLAB, it is not possible. Whatever MATLAB we are using, right, to execute the logic through DSPACE, that MATLAB is acting as a only this MATLAB, it is useful. MATLAB program is useful to transfer the logic in matrix to C file. Right? So finally, that MATLAB, it won't work after executing the program. Once your program is executed, all information will transfer to the controller. If you want to change the reference value, right, in the controller dynamically, it required DSPACE software. That is, control desk is required. This control desk is so important to change the variables dynamically under operating conditions. MATLAB program, this is called MATLAB logic. By using this MATLAB software, we can transfer the logic to the controller. Once logic is transferred to the controller, later we cannot change this value through MATLAB. Even if you change this value here, it won't change through the controller. If you want to change the reference value under running condition dynamically, you have to access this. The significance of the control desk, this is about pin numbers of the IO pins, right? So master output, right? So you have to assign the pin number so that corresponding, see, 1 to 37 pins are available. Out of this 37 pins, some pins are assigned as a ground, some pins are assigned as a input, some pins are assigned as a output or input port. Same pin you can use for input. If you want to transfer the data, digital data to the controller, or if you want to extract the information for the controller, this pins are you can use as a bidirectional. It is not a problem. Only thing is, see, you need to take care about magnitude of the signal. The expected output magnitude of the controller is maximum 3.3 volts will come. If you want to activate the semiconductor switch, again it required amplifier. By using amplifier, we can we can activate the switch based on our requirement, right? See, what is my request is, see, extract understanding this one, executing the logic through DSPACE, it is not a big problem. Only issue is, first you need to identify what is the significance of controller, how how to extract the characteristic equation. Based on the characteristic equation, if there is in actual system any problem is there or not, you need to identify any dominant pole is there or not, any disturbance is there or not, you need to identify. If there is any disturbance is there, whether feed forward control is really required or not, you need to analyze based on the characteristic equation. If there is any dominant pole, a serious issue is there with dominant pole, right, you need to take care about the dominant pole effect in the system, right? So first my request is, you need to understand the significance of the actual system characteristic equation. So after that, once you know the system characteristic equation through mathematics, it is not a big deal to design the control parameters. Once you know the control methods or particular system, it is not a big problem to implement in DSPACE software, DSPACE controller. DSPACE controller front end is MATLAB only. MATLAB is very user friendly. It is not a big problem, right? So participants, if you are having any doubt, you can ask. Clear? Shall I stop here? Already 10 minutes exceeded. If you're having any doubt, you can ask, so that then after that we can conclude the session. Fine. I don't know how many students got, how many students see this session is session is useful or not. I don't know, but see, thing is, you have to see whatever engineer explains. Same thing, if you follow for particular system, it is not a big deal to identify the problem facing by the actual system. You will get clarity. Identify the problem in your particular system is a very big challenging for design engineers. Fine. Shall I stop here, participants? If anyone having doubt, you can ask.
Vinay sir, can you stop sharing the screen? If you have any doubts, you can really again contact Dr. T. Vinay Kumar over email also. Okay. Yeah. Then again, we'll close the session. We'll come back again at 1 p.m. Okay. Thank you.